Live. Can everyone hear me okay? All right. Hope you're having a great reInvent so far. First couple days have gone by. Thank you for coming out for a slightly late session. I know there's some happy hours going on already. Thanks for coming and joining us and spending your time with us this evening. So this session is going to be PEX304. And today we're going to talk about next generation SaaS. We're not going to just focus on the SaaS we're building today, although we're working with lots of SaaS customers. Between John and I, we've worked with dozens of SaaS customers over the last couple of years. But we're going to focus on the SaaS that's coming 3, 5 years from now, around the next corner, around the next bend. We're going to think about how things work today and where they're going to end out in the future. And we don't have a crystal ball, but we do have a lot of insights from the customers we're working with, the changes that they're seeing happening and where they're going, especially when we think about how they scale, how they build resilient solutions, and how they try to maintain operational efficiency while they're doing so. So my name is Bill Tarr. I'm a principal partner solutions architect with the AWS SaaS Factory, and I'm lucky enough today to be joined by John Topper. So John works, the founder of the Scale Factory, who was our SaaS Competency Partner of the Year, Global SaaS Competency Partner of the Year in 2023. So thank you, John, for joining us.
Thanks for having me.
All right. We're going to get right into talking about what we mean in terms of SaaS. Oh, sorry, I was a slide behind. We're going to get talking about what we mean when we talk about SaaS and some of the complexity that we see when we build SaaS. And it starts to creep in when we think about design. When we start designing a SaaS application, we're drawing on the whiteboard, everything seems really simple. But we're figuring out the problems we're going to solve and we start to build. What is this going to look like? And it might be very simple for a SaaS application. Maybe a simple EC2 with a database behind it, an S3 bucket for your web pages. Maybe that's all you've got right now. But the complexity really starts to creep in when we grow SaaS and we start to scale. We get to the 10th customer, you get to the 100th customer, and all of our problems start to multiply. And we have to figure out how to operate this solution and manage all of these different customers. And our team can really bog down in the day-to-day of the DevOps story, of understanding our customers and the experience that they're having. All of these things lead us to the need to optimize, to start to remove some of this complexity and come up with solutions that will work better to continue to scale our application across more customers, more accounts, and more AWS regions. So when we're making decisions about how to scale our applications, one of the things I want you to focus on in this talk is where is the complexity creeping in? When do we start to see complexity appearing in our application? And when we make decisions about what we're going to build and how we're going to build it, are we really factoring in the return on complexity of the decisions we're making? For example, build versus buy. What's the decisions we're making where we're choosing third-party software or even choosing AWS services that might remove some undifferentiated heavy lifting from us and our teams rebuilding things that already exist? What's the return on complexity in terms of our control plane investment? When do we need to make that investment? When's the right point to start thinking about managing our application at scale? And then our DevOps story. What are the tools that we're using? What's the timing of compliance and when does that start to appear on a roadmap? What are the complexities that DevOps introduces that we need to handle? And then, of course, multi-tenant storage. Storage is one of the biggest problems we see with customers who are hitting their scale in terms of what can constrain them from coming up with new ways of growing their application. And we're going to end the talk thinking a little bit about the next generation of GenAI. We're going to look at an example of a partner who's already using GenAI to help their customers reduce the complexity of using their product. And we're going to think about the next generation of what that might look like and how they might be able to build a multi-tenant solution that will solve even more problems on their tenants' behalf. Now, I'm going to hand this off to John in a second to start talking about orchestrating cells. And by this, we do mean cell-based architecture and how you manage cell-based architecture at scale. How do you build an application that you can manage and continue to operate with a small team, despite the fact that you now have many different cells of customers that you've spread, maybe across AWS accounts, maybe across regions. So John, I'll hand it off to you.
Thanks, Bill. Good afternoon. So we're going to talk about a customer we've been working with now for maybe a couple of years called Automata. They're in an unusual space for a SaaS business because the platform that they're building, although it's a software platform, it's actually orchestrating hardware that lives in their tenants' environments. And we're not talking servers and switches and that sort of hardware. We're talking about robots that are managing long-running experiments in laboratories. And so the requirement that they have here is to be able to manage these long-running experiments from the cloud on hardware that is actually present in the buildings that their staff are working in. So that means that it needs to be highly reliable, obviously. There's no point having an experiment that runs for weeks at a time that's suddenly not working out and has to be started again because the platform isn't available. And so this is a consideration when we're looking at the design here. And there's also a need to strongly isolate tenants from each other. That's not unusual in SaaS particularly, but often you'll find that the isolation requirements of a SaaS business will vary based on the size and shape of the customers that they're selling to. And so for their first batch of customers, they are particularly concerned about isolating data from one another. Over time, it's fairly standard for a SaaS business to maybe look at a larger market once they've sold to larger entities in that space, to start then trying to figure out how they can sell to the mid-market and how that changes the business model. That typically means that you end up working with more cost-motivated customers at the smaller end. So there's all these things to consider as we're thinking about the design here. So this is the type of hardware that we're talking about. These are built from third-party components. So Automata don't build the hardware themselves, but they do deploy a team of engineers into the laboratories to put this stuff together, make sure it's all working with each other. And these are sort of robots for moving Petri dishes around and for maintaining temperatures and that sort of stuff. The type of thing that you might imagine goes on in a lab, but taken care of over long periods of time, very precisely by robots, essentially. And so the work that we're doing with Automata looks at what we're going to call today the two halves of SaaS. I don't know if halves is necessarily an accurate division, but there are two areas of consideration. You'll probably, if you're building SaaS today, and I imagine many of you are, which is why you're here, most of what you're concerned with on a day-to-day basis is the application services that you're running to present services to your clients. So you've got web applications, maybe you've got some services in the back end, and then some storage infrastructure to support that as well. And in this diagram, what we see here is this is one customer's or one tenant's infrastructure, and that's the isolation model that you typically want to start with if you're dealing with these sort of larger, more isolation-concerned customers. If you're supporting a larger number of customers, you might think about a pooled tenancy model where the same sort of infrastructure might exist, but those components will be shared across multiple tenants. So these web applications, these services, these databases are all then shared between different customers. And obviously, the isolation story becomes different in that case, but we'll get onto that a little bit later. And we're calling this the application plane. So this is where your developers are mostly spending their time. But when we think about the other half of the SaaS story, there's the control plane. And these are another set of applications that are running distinct from the application plane services that handle things that look a little bit more operational. So onboarding of tenants, managing those tenants, managing billing. Hopefully you're billing your customers. That would be a good thing to do from a commercial perspective, measuring metrics and so forth. Over time, this sort of evolves. You'll almost certainly end up with a sort of situation where inside your application plane you have workers of some kind handling the application side concerns around tenant onboarding and so forth. So you might be thinking about building a control plane in your world. You might already have started. I think if you're looking at control planes as a topic, one of the things that you can go and look at is the SaaS Builder Toolkit, which is a free resource from AWS, which is a reference architecture, if you like, for this type of thing. What we find in the SaaS world is that most SaaS products need some kind of control plane deploying, but they are almost always very customized to the needs of that specific business. But starting with a reference architecture is a good thing to do. So the SBT doesn't really have any opinions about the application itself. Those are all for you to concern yourself with. But the control plane implementation provides a number of reference implementations for things like onboarding and so forth. The control plane also comes with an API, of course, because this is how we do things in the modern world. That API is accessible from an admin console and a CLI, which are provided as part of the SBT as well. Inside the application plane, you've got the workers that do things like user provisioning and so forth, once orchestrated to do so by the control plane. If you're familiar with Event Bridge, that's the communication mechanism that's happening here. So as things go on in the control plane, events are put onto the Event Bridge bus that are then consumed by the workers in the application plane. That's how we sort of separate those concerns. And SBT also provides point solutions for things that you might come across frequently, such as the ability to create a multi-tenant way of thinking about deploying SQS dashboards and so forth. So let's talk about the cell deployment model now. We promised that we'd be talking about that. And this is work that we're doing with Automata and a sort of model with which we're thinking about this for them. When you start building your SaaS, you're probably going to be thinking in these terms. So think about deploying all of your tenants, all your customers onto the same infrastructure. This is very common. The customers that we work with almost always start in this space. And over time, that becomes a problem because if there are incidents that take out parts of that infrastructure, then they're going to affect all of your tenants. So this really broad blast radius where everybody's upset if you have some kind of problem. And so evolving from there to a cell-based deployment model allows you to get away from that to some extent. So in this diagram here, we're showing that the purple tenants are deployed into cell 1, the blue tenants are deployed into cell 2, and the orange tenants into cell N in this case. And so you can see that if you lose one of these cells, the only impact is to the customers that were in that cell. The other cells continue to run. Now, this isn't just a consideration in terms of availability or blast radius. You might want to divide your tenants across cells for other reasons as well. So one way of thinking about cell distribution, if you like, might be about the sizing of your customers. So you might have a cell that has your general customer pool. So the people that are most commonly buying from you might go in one cell. You might have a set of high-paying white glove customers where you're providing a much higher level of service and guaranteeing them a much better level of isolation from noisy neighbors and so forth. So you might put those in another cell that has fewer tenants in there. And if you've got a freemium model where some of your customers are perhaps not paying you very much, or if at all, they're still important to you, obviously, because hopefully they will become proper paying customers at some point. But they are, you can put them on hardware that is shared with more tenants because you're a little less concerned about the experience that they're having. And so you might think about it in those terms as well. So that means then that if we're building control planes to orchestrate some of these considerations, then these control planes also need to become cell aware and start working with the sort of cell architecture that we're thinking about. And so this is the control plane diagram from previously. It now grows another component, which is the cell management component, which handles things to do with cells, cell routing, and so forth. We call it routing here, don't we? Cell routing. And so these are just the cell types that we talked about before. You can see then that the control plane now has to think about dealing with cells as well as tenants. And I think this is where the next generation is going. We're seeing that being a topic of conversation across more of our customer base. And the responsibilities of a control plane, cell orchestration service, if you like. Obviously, we have the SaaS control plane we've talked about already. We might want to create new cells in an automated fashion, for example. So our cell management orchestration tooling needs to be able to create cells, provision new infrastructure. You could see this interfacing with something like Control Tower, for example, for vending out new accounts with cells in. If you're doing cell distribution based on sort of moving of load around, then over time, if you have customers that come and go, you might end up with cells that are imbalanced. They might be particularly busy compared to other less busy cells, in which case the cell management orchestration needs to be able to rebalance and move tenants around between the cell infrastructure that you've deployed in order to balance that out. And you might also have cells that resize relatively dynamically with load. So you might know that you've got some more tenants coming up, so you'll resize the cell outwards in order to make room for that tenant, and then provision the users of the new tenants on there using the existing onboarding tooling as well. So if this sounds like DevOps stuff, I don't know whether I've made it sound like DevOps stuff, but to me, this is DevOps stuff. Traditionally, your DevOps tools, we certainly 5-10 years ago were using automation tools to provision tenants into infrastructure for customers. We weren't necessarily thinking about it in terms of control planes as a sort of application in and of itself. And so I think what we're saying here is that rather than being entirely new tooling, the one way to think about a SaaS control plane is as a layer of cell and tenant aware orchestration around existing DevOps tools, and that's certainly how we're seeing them implemented in the wild as well. DevOps, of course, very important. Bill.
All right, thank you, John. So why do we care so much about DevOps? And I'll kind of split this into a couple camps. And over the next few slides, look for these same topics to appear over and over again, because these are recurring concerns for a SaaS application. And the first one is configuration. Now, if you've ever heard us talk about SaaS before, you've heard us talk about configuration versus customization. If you're building a SaaS application, I want you focused on a single version of your software wherever possible. I don't want you going and configuring your application for a specific customer, customizing your application for an existing customer. I want you to do configuration. I want you to be able to change their user experience at runtime. On the other hand, we have a lot of concerns about onboarding, about deployment processes, and we'll focus on those in the next few slides, because this is really where a lot of the complexities creeps in. Of course, configuration can bring its own complexity. How are you managing feature flags? But the onboarding and the deployment processes bring quite a bit of complexity in terms of the number of tools and the scope of what we have to work with. So what does it look like for onboarding SaaS? Now, on a theoretical level, it might look something like this before we get into the tooling. We might need a deployment pipeline, which creates our initial environment. If we're doing any sort of pooled resources, well, we can create those now, because we know we're going to onboard tenants into those shared resources. Then we have to worry about the onboarding story. So we're going to start onboarding tenants into this shared environment that we've created. And now some of these concerns start to pop up. Now we have to think about configuration. How do we configure our tenant experience so that it's differentiated for every user in this completely shared environment? They're all using the same version of our application. By definition, there has to be some configuration here. How do we think about user management? How do we do metering and billing? Hopefully we're getting paid for our application. If so, we've got to embed some metrics that talk about what we're going to bill our customers. Now, of course, we also have to think about tenant provisioning in the case where we have silo customers. So we use this terminology, pooled versus siloed, so that we can kind of differentiate between these isolation models. These silo customers get their own stack of all of their own infrastructure, and their use case is similar, but now we've introduced a couple more complexities. Now we have to worry about tier configuration. We might have a basic tier of our product. We might have an advanced tier of our product. How are we pricing those? How are we understanding the user experience across those? Is it differentiated in some way? Do they have access to features that other tenants don't have? All of those concepts come in, as does routing. So we've already mentioned routing. How do we get these tenants into their specific environments from the outside world? And we go back to our deployment pipeline, because we're not going to stay in the same version of our software forever, I hope. Hopefully, we're going to continue to introduce new versions of our software. We have to land that software into these silo environments and into the pool environments. And of course, offboarding. I never want to talk about onboarding without mentioning offboarding. By the time we're done here, some tenants are going to want to leave. They're going to decide that they don't want to use our product, or they go out of business. Whatever the use case is that causes them to stop using our product, we have to be able to clean up all of our infrastructure, because leaving anything behind, of course, might cost us money, but it might also be a security exposure that we have that we can avoid. So we want to make sure we're cleaning up all our resources when we're done. A lot of pieces, a lot of moving parts before we've even got into the tools we're talking about. So let's get a little more concrete now and think about a simple EKS implementation. So if we wanted to deploy EKS in a multi-tenant environment, we might create a configuration repo. In there, we're going to have some Helm charts, or we're going to have some Terraform scripts. All of these things start to add up. We might end up with multiple Terraform scripts, multiple Helm charts, all of which have their own outputs. When you run any kind of script that creates infrastructure, that onboards a tenant, there's going to be outputs, things you have to remember afterwards. So in this scenario, we're using already Helm charts, Terraform. We'll use Flux to keep the state of our Kubernetes resources in sync with our existing configuration repo. Now let's start onboarding tenants. We onboard one tenant. We go out and retrieve our configurations. We deploy our resources onto AWS. And now we create a tenant version of our configurations. So we're going to maintain a configuration per tenant, a fairly common model. Now we onboard a second tenant. Now we've got another tenant configuration. Sorry, clicked too fast there. Now we're going to have another configuration. So now these things start to add up, right? And we've got Argo workflows introduced here. Argo workflows are going to allow us to deploy our application. We've got Helm charts, Terraform, Flux, a lot of moving parts. Now, I'm not knocking any of these tools, mind you. Anyone who's doing DevOps in the room today recognizes these are all great tools that help us to do the jobs we need to do. But what I really want to emphasize is all of these different activities that are happening are emitting outputs. And somewhere our DevOps engineers have to be tracking all of these things. And if you think it's easier in serverless, you're kind of right. You're a little right. Serverless is easier in some ways. But it doesn't absolve us from the same responsibilities we have in EKS. The tool stack is just a little bit different. We've got to do some tenant provisioning. I've got to keep track of what I deployed for each tenant, where I deployed it. And we're going to run some sort of pipeline, right? We're going to have a repo that we're going to deploy. We're going to do some builds. We're going to do some deployments. Eventually, we're going to run some CloudFormation stacks somewhere, whether running those with Terraform, whether we're doing that with CloudFormation itself. And the end result is going to be a bunch of infrastructure we've created that we've got to keep track of now. Maybe it's just Cognito, API Gateway, Lambdas, DynamoDB. Maybe it's something entirely different. Maybe we're using Auth0, MongoDB Atlas, and a bunch of third-party products that we need to keep track of the keys for, what we're doing there, and what we've actually provisioned for the tenant. And then, of course, we've got to keep track of all of these tenant configurations that we've done and the tier configurations that live behind those. So this serverless, while the tool chain may be a little simpler in some ways, it doesn't absolve us of the responsibility of keeping track of the output of all of these different operations. So when we start to think about the next-gen operations, I'd like to have something that created this stack and could help me maintain the state of everything within this stack. Wouldn't it be nice if there was a third-party product that kind of did this and thought of this in this way and said, listen, I'm going to create a control plane. And in creating the control plane, I want to create a digital twin that represents that control plane. Now, if you're not familiar with the term digital twin, NASA actually came up with it not that far in the distant past. In the 60s and 70s, they were sort of using this concept already. When you create a rocket, it turns out it's fairly expensive to blow up a rocket to test a rocket. So they would create digital twins based on how they created the rocket and all the telemetry and everything they learned about the rocket over time. So that when you looked at any time slice, you knew exactly what was on the rocket, what the rocket was configured as, where it was, all of the pieces of the rocket. So I kind of like to apply that same concept to DevOps. So when I keep going down from my control plane, I actually want to inform my control plane to create a new AWS account. And what I do, I want to keep that state of what was created in my control plane concept, if you will. Then when I start to build out my account, I might create a cell router, keep track of the subdomains that I'm assigning to it, create a management cell that's responsible for deploying cells, tell it which cells it's deploying, where those are deployed. And from there, I keep going down. I'll start to create cells, and the cells will start to inform our management cells of what's going on and where we're putting things. And I'll start to deploy tenants into there. And this is really where the life cycle of SaaS really starts to explode. Because our tenants aren't simply onboarded. They continue to morph over time, as does our infrastructure. So I want to keep track of a lot of information about my tenants. Where did I deploy them? What version are they running? What payment gateway were they assigned to? We might have multiple payment gateways. Maybe they're using Marketplace. Maybe they're using Stripe. And I have to keep track of my identity provider. We might have different identity providers for different users. What's the story there? What's all of the outputs I got from onboarding that service? And then we're going to continue to operate this tenant over time. We're going to collect payments from them. We want to keep track of the state of their payments. We're going to apply some configurations. And we're going to apply one configuration, and then tomorrow we're going to deploy another one. All of these changes over time continue to inform this digital twin that we've created. So all of these, if you want to think of them fairly accurately, they're durable workflows. These are not things that happen once. Rather, over time, they continue to evolve. I would love it if I had something to describe my control plane, and I could look at it over time and say, this is when we did this. This is when we deployed that. This is when we added this cell. So when I was working with John's team, Andrew, one of his solutions architect, who was, worked on Autonoma and a lot of other customers as well, had the same sort of problem. Lots of different tools he was working with, lots of outputs. And we had a great conversation about what this might look like. So going back and thinking a little bit about what this might look like in the real world, he's got a control plane. He's got a management account that runs Control Tower. He's got an account for routing that uses DNS and Route 53. And of course, he's got all of the cells that he's deploying. And what third-party service might be able to actually provide a lot of the value that we're talking about, creating durable workflows that he can use to maintain the state of all these parts of his application. And he came up with Temporal Cloud. And I think it's a really interesting solution for this. And this is where I think we're already starting to see some adoption in terms of SaaS providers trying to do this exact concept. You can put temporal workers, which are just, they could be any type of compute, but you could deploy them into your control plane, and they could be responsible for deploying AWS accounts, for managing our routing and keeping that up to date. And we can use other temporal workers in each one of our cells, put that into our management cell, and have it be responsible for creating cells, onboarding tenants, and maintaining their states. And the cool thing that I like about temporal other than the fact that they use temporal to build temporal and deploy on temporal cloud. So they have a great dog fooding story for their own product. Other than that, the thing that I really like about them is this state of durable workflows is native to what they do. You can use temporal to create these workflows, restart them, rehydrate them, stop them, pause them over time, and then continue to nest them all the way down. So if you can look at this, it literally is workflows all the way down in terms of managing this. And we've already seen some really interesting customers. Red Panda is doing something along these lines. Atlassian is doing something along these lines. Stripe is using temporal. All of these different AWS customers are already building really interesting things with temporal. I think this might resemble something that we see in terms of the next state, the next generation of SaaS. Something that really keeps all of these states together. Whether it's temporal, whether you pick a different tool, I think thinking of DevOps in this way will really start to simplify some of the complexity that creeps into our DevOps story. So we've gone through one customer use case already, and John's going to introduce another customer use case. And this one has different constraints. I want you to listen to some of the complexity that the customer brought in this case that made some different decisions. So we didn't end up doing exactly the same thing with this customer. Instead, given their compliance constraints and given the complexity that their business had, John's team made some different decisions and came up with a different solution to some of the problems. Thanks, John.
Thank you. So scaling is obviously important enough that I put it in the name of the company that I founded in 2009. When we talk about scale, we're not just talking about, I guess, the sort of scale up of the compute, although that's important as well. We're also talking about the scaling up of the business and the kind of size of the organization and everything else as a SaaS business evolves over time and matures. As that type of scaling dimension happens, there are a number of things we need to consider to make sure that growth is managed efficiently. It's very key that we maintain tenant experience as the needs of the platform increase and as the size of the business increases. These are the people that are generating our revenues. We need to make sure we're maintaining our SLAs and keeping our promises to those customers. So that's sort of front and center every time we're thinking about these things. We want to think about scaling to usage. So as the needs of a tenant increase or the needs of all of your tenants increase, it's important that we are scaling up the resources that we're providing to them in terms of cloud resources in a way that is consistent with their needs. So we're scaling to the usage and not beyond that. And related to that is aligning resources with costs. So not over-provisioning just because we're getting bigger, thinking about these things and keeping costs in check, obviously very important, because otherwise you're going to be passing those costs on to your users. And some users, as we'll see, are more cost sensitive than others for various reasons. So the use case we're talking about today, I can't name the customer, but they're a pharmaceutical business. I used to have hair when I founded the organization originally, and when I had hair, I was working with this customer directly. I was hands-on keyboard consulting with them. Since then, I've sort of gone to running the business rather than doing the work. But this is how long the relationship with this customer has been. We're talking sort of 12 or 13 years at this point. So a very, very long-term relationship, and we've seen them evolve over time. So we've seen that story and the sort of inflection points as we go. So they're in the pharmaceutical space, which means that they are required to follow regulatory compliance guidelines under GxP and GAMP. And these are change control guidelines, essentially, and we'll talk a bit about what that means. Their customers are large pharmaceutical businesses. You will recognize the names of their customers. That's printed on the drugs that are in your house. Some of the drugs that are in your house, maybe not all of them. And as a result of that, they have very strict isolation requirements. So it's important that one pharmaceutical business doesn't have their data leaked such that another pharmaceutical business will see it. This is commercially sensitive data, of course. Under the GxP and GAMP guidelines, change is managed really carefully, and so their customers who are spending quite a lot of money on this platform and are themselves regulated by these standards have long user acceptance cycles. They call it qualification. So as they make changes to the application, these changes have to be put in front of the customer, who will then deploy a test team to qualify the application still meets the requirements. And it's a very sort of rigorous process, and it takes a long time, both manual and automated testing. As they've evolved, they've discovered a greater need for cost efficiency. So when you're selling to big ticket pharma businesses, Cost sort of doesn't matter in the same sort of way that it does when you are selling to smaller pharma businesses. And so they started by selling small numbers of large deals, and over time started to sell to the mid-market. And we had to bring the cost down of running a tenant because otherwise that market wouldn't be able to withstand the pricing. And what they're doing is handling drug safety feedback information. And so the thing that's the most important to them is not necessarily availability, although availability is important. The main thing is that once a report has been made into the system about a reaction to a drug, then that report needs to durably get to where it's supposed to go and not be dropped on the floor on the way through. So these are the sort of SLAs that we're talking about. It's got to be 100% durable, and that's the promise they're making to their customers. So we're supporting multiple environments for them, and I think if you're a SaaS purist, the idea that your tenants all have different versions of software with different modifications to features and so forth is a little bit twitchy. You'd rather not have that in an ideal world. Unfortunately, in this type of industry, because of the nature of the qualification process, the commercial reality is that it is necessary. And so what you have for this customer that we don't usually see across the board is that every tenant has a sandbox environment in existence as well from time to time for trying out new features and testing code. We also then provision a UAT environment for them to do their formal qualification testing on when there is a new version to deploy. And of course, we've got the production environment as well. So you can see that the pricing or the cost of this stuff starts to ramp up when you've got so many environments per customer in a way that's not especially standard in the SaaS world. They'll have long-running versions. So because of the nature of the qualification process, we're talking about making changes every quarter or every year or something of that nature. Bug fixes notwithstanding, but the bigger feature releases are much less frequent. And so you might have, for example, in production, you've got version 1 for all customers, but maybe tenant 2 is on version 1.1 in their sandbox and their UAT environment and so forth, which is why we have to have these environments on a per-tenant basis. Originally, this was a platform that was built actually not on the cloud. We migrated them to the cloud as part of a project that we did some number of years ago. And then from there, when we went on this journey to reduce the cost of running a per-tenant deployment so they could sell into the mid-market, we adopted a modernization approach and turned the application into containers, deployed it onto EKS. And so we're using Carpenter with this customer here. Carpenter is it's an open source product from AWS. It's a really good alternative to Cluster Autoscaler. Those of you paying attention this week will have heard that there's a new auto mode EKS. This isn't that, but Carpenter is sort of implicated in that. The Carpenter solution works directly with EC2 APIs and has a good understanding of AWS's pricing model and instance types and so forth. And so it can make really well-informed choices based on what it knows about how your application runs and what AWS can provide. And so that allows for rapid scaling. The calls that Carpenter is making to scale up are directly to the EC2 API, so as quick as they can be. They can do automated node resizing, so that as a workload changes shape, nodes can change shape to deal with that as well. As workloads reduce in size, then nodes can be consolidated, so you're running less hardware or less compute. And because of the knowledge that Carpenter has of the AWS platform, it can choose compute solutions that are well informed in a way that the cluster autoscaler, you would have to tell it a lot of these things yourself. So Carpenter allows for efficient scheduling. In the event that you're scaling up a tenant or you're maybe spinning up one of these UAT environments for a qualification run, you'll be generating new Kubernetes pods. And these pods, if there's nowhere for them to run, Carpenter's going to recognize that and start to provision new compute nodes so that those pods have somewhere to execute and that you're still maintaining the experience that the customer needs as far as durability and availability is concerned. Over time, Carpenter can reallocate your node usage so that it's using the most optimal solution for the workload that you've got right now, and it'll do all that automatically as well, all still whilst conforming to the scheduling constraints that you've given the application. I've just talked through that whilst looking at the slide that wasn't on the screen. Sorry about that. So what we've managed to achieve and what we will continue to work with this client on is cost savings and compliance. So this isn't the current state. This is a future state that we'll get to with this customer ultimately, where the sandbox environments, because they are used periodically as new feature work is going on behalf of that customer. They don't need to exist all the time, and the durability requirements for the sandbox environment are much lower, and so they can go away without too much of a big deal. And so Carpenter can schedule those kind of things onto lower cost compute, possibly spot instances if you're quite happy for those instances to disappear at times, and to right size the compute requirements for that infrequently accessed workload. In the UAT environment, we know when this qualification process is going to happen on a per tenant basis. This isn't all the time. It's in a specific window, and they gear up for it. It's prepared for it. It's project managed, and so you know that there's a window of time when those testing activities are going to happen. And so we can scale the UAT environment down to nothing when those activities are not happening. We can also choose to scale those down to nothing outside of office hours when their testers are not working. And so when they come in the morning, or if someone's working late or over the weekend, as sometimes happens with these kind of deadline-driven release trains, then we can just in time scale it up and not cause too much consternation with the customer's testers. And in the production environment, this isn't something that we're doing currently, but this could scale up in real time. Now, in real terms, this customer's workload is quite predictable. It scales fairly predictably, and so we're not dealing with spiky activity. So we may never get there entirely with this workload, but it would be possible in a spiky workload to deal with that. The other thing that's quite nice about the way we're using this tooling is that the compliance standards require that they throw away compute periodically and replace it as a way of mitigating against nodes that have been broken into or otherwise sort of accumulating cruft. It's good practice to be doing that anyway. And so the time for which a node lives can be one of the constraints that you give Carpenter to manage as well. So over time, it is cycling out those nodes or those pods so that they're not going to be hanging around for too long, but crucially doing so while still maintaining the scheduling constraints that we've put on this workload so that the SLA for the customer is still met. So the next generation, and I don't know whether this customer will end up here, but the application that we're talking about here is a fairly monolithic Rails application with a Postgres backend. There's some queues and other things. You'd recognize the type of application that it is. But if you were to evolve that application, if there was a need to evolve that application, you could consider taking that monolith and breaking it up into pieces. And if you break a monolith into pieces, you get other benefits that you can leverage from something like Carpenter, where, for example, some of the compute might be event-driven. So customer comes and submits a report, now there's an event happens, and then something else can happen. And if that is the case, then you can deal with the compute needs of that workload on an on-demand basis, and some of those compute needs could be handled by spot instances, and you've designed that into the architecture itself. If you're decomposing workloads, so some of the services of a microservices-based platform are not in use all the time. And so you could see that those could scale into zero when they were not being used and scale up when they were. And there's a bunch of other architectural decisions that you could make around this type of application if there was appetite to decompose it to that extent that then align with the other benefits that you get from Carpenter and improve the both cost and compliance and SLA meeting condition of the application in doing so as well. So we looked at cell-based architectures earlier, and for those of you who are sort of familiar with database sharding, these are sort of similar kind of thinking. And Bill's going to look a bit more now at tenancy considerations for relational data, and he's going to use the word sharding a bunch.
Thanks, John. So if you've built SaaS applications, if you've worked with SaaS customers before, you've probably seen lots of relational databases. Not everyone's using them. I love DynamoDB as much as everybody else. I'd love to see more NoSQL, but I don't think relational databases are going away anytime soon. But multi-tenancy has always been something of a challenge for relational databases traditionally. Now, what are some of those challenges, and how do we picture those? We'll set some of the context for where we see the next gen going. Because some of the things that I think are missing are an easier way to adapt different isolation models for our tenants. So when our tenants switch from one isolation model to another, how do we move that data around in a relational database? That could be one challenge. How we back up and restore the data, a similar challenge. What happens if our tenants access to take their data and put it into a different instance? What happens if they want to take their data and we want to use in the UAT environment we were just talking about? How about scalability? Speaking of sharding, how do we set up a proper scale, and how do we focus in tenants on the right instance sizes? How do we spread their data across different constructs within a database has always been a little bit complex in terms of a relational database. Having an API-driven experience. Almost everything else we're using, every third-party product is API-driven now. Why is it that we're still using all of these older tools and creating connection pools, connecting to databases, and having to think about these things every time we're using a relational database? And then finally, I'd like the experience just to be easier and more fun as a developer. I don't want to be dropping down into all of these random tools that we're using. I'd like it to be very simple. I'd like to think of it just like I think about Git. We have kind of solved the code problem and how we manage code and how we think about the state of code over time. Why is it we're still thinking about our database as kind of a separate entity, and it doesn't have the same understanding of what the state of the schema is and what the state of the data is? So why are these things a challenge? Let me just go over a couple of these challenges. We have different isolation models, and these apply to our database the same way they apply to our compute. We might have silo isolation models where every tenant gets their own instance of Aurora or RDS. If we're using something like Postgres, perhaps we have a schema per tenant inside the same instance of Aurora or RDS. Or we might use a tenant discriminator, simply a column in our database that defines the tenant who owns a specific row, and then at runtime, we define who can access what row using our row-level security or some other security mechanism. Now, one of the problems we run into here is how we shift data between these models. And this can be a little complex. If we move tenants from a tenant discriminator model into their own schema, or from a schema into their own instance, we often need to use tools that are provided by the database. There are some best practices we can use to avoid some of this, one of which is we can use a tenant discriminator, if we're going to use it at all, across all instances of our database. So even if we're doing a completely isolated model, include the tenant discriminator. That way our schema is consistent across all of our isolation models. And when we want to switch between them for different tenants, we can easily do so moving downward at least. Although we still kind of have the problem that moving upstream is still going to be a little bit more of a challenge. Another challenge is the complexity that's introduced by sharding. So we said we're going to say sharding a lot. We're going to say sharding a lot on this side. Keeping these queries and understanding how to keep queries from crossing over different instances. Like this is just a mapping here. It shows which partition belongs to which tenant. How do we keep the queries for a given tenant from going across multiple shards and having to combine that data? How do we maintain the mapping of all of these tenants? How do we actually think about this? Do we go and have to look up where the tenant's shards are before we even run a query? Making these complex queries and actually doing joins across different entities. What's the resiliency story here? If we lose a single instance, if we lose even a single schema in a database, does that take a tenant down completely? Do we have some sort of shuffle sharding or some other scheme in here that provides some resiliency? And then finally, how do we actually pack in these instances? How do we say this many tenants should live on a single instance? Does that change over time as our tenants grow? Do we have to monitor that and understand the state of every instance? All of these are complexities that are introduced by even modern relational databases. So I'm going to have 3 separate slides here for the next gen because I think we're still starting today to see the next gen emerge in phases across different applications. The first one I'd like to talk about is Aurora Serverless. I've had quite a few customers already using or looking at Aurora Serverless over the past year. One of the big things I've been really excited about is the data API being reintroduced just a few months ago back into Aurora Serverless version 2. Mostly because as I'm thinking about a SaaS application and what I have to do as a programmer working in a SaaS application, I have to understand what I'm going to do with this tenant traffic and how I'm going to route that back to the database. And one of the complexities that's introduced is, we're accessing this database, we've got the multi-tenant data, I've got to manage all of the connection pools. And those can get quite complex in a SaaS solution. I've only got 3 tenants here. What happens when I have 100 all using the same compute instance? Well, the connection pools now have another variable that's been introduced into their context, and it's going to keep growing and growing and growing, and it will start dropping some of those connection pools over time. So now I have to think about connection pinning. How do I pin a specific tenant's connection to the right instance or the right shard? All of these things that are challenging to manage. And what the data API allows us to do is push all of that back onto the database engine. When I'm using the data API, it provides connection pooling for me. I no longer need to worry about what it means to do multi-tenant connection pooling. And that's a level of complexity that just dissolves if I'm using Aurora Serverless. So this is one interesting innovation that I'm seeing that I think is going to start to play out more in the future. And I mentioned, as a developer, I really want to think of my data, my schema, the same way I think of my code. Wouldn't it be great if I could just say, over time, these are the different versions of my database. This is the schema that we were using, and perhaps here's the tenant data at that exact point. What if I could just, as a developer, say, I'd like a developer instance, instantly have that, branch it off, refresh the schema from what's current in production whenever I want to, and then create other instances, perhaps a staging database, perhaps that UAT database, and merge my tenant data into my developer data into that over time. And then I also, perhaps this developer database, maybe I want it to scale to 0. I don't want my boss to be yelling at me because I left it on over the weekend and my developer instance cost us more money. I want it to scale down, and I want it to turn itself off if no one's using it at all. And eventually I just want it to go away. I'd like to think of this just like I think of a branch in my code where I'm done developing this branch, delete, gone, no more developer database. Now I can go to get a fresh one. And I also would like to have my tenant-specific data be able to be restored to a point in time. I'd like to be able to understand the exact state of where my tenant's data was at any given time. Now, if this sounds fairly concrete and like someone's actually thought this through, somebody has. This is actually, I'm using NeonDB here as my sort of benchmark for developer experience. I like a lot of the things that they've built. It's a cool third-party service. They're an AWS partner. And they manage Postgres. So if you're using Postgres flavor, you're in luck. If you're not, so be it. And you can actually figure out all of these different pieces within NeonDB. You can easily spin up. You can branch your versions. And of course, they manage sharding on your behalf as well. So another cool side benefit of using NeonDB. And the third innovation that I've been excited about since last reInvent is Aurora Limitless. Now, Aurora Limitless is probably useful for a lot of different things, but where I think it's particularly compelling in a multi-tenant solution is the fact that it will manage the sharding across different schema entities on your behalf. So for example, if you had an order table and you wanted to shard this across different instances for performance, for scale, for reliability, you can actually pair this with a tenant database, and it will map the tenant data to the order data, and it will put the tenant data into the correct shard for your data, so it matches to the other tables that have the tenant-specific data. And you can also create reference data. If you don't want to do this, you can also spread your data across the different instances. And this just gives us a nice, simple way to manage this problem of sharding across databases. And it's out of the box today. Aurora Limitless is still growing. I think we're going to see a lot of cool things coming out of this. And all of these different solutions solve different pieces of the problems I was talking about, the different complexities. So I think the next-gen story really is we're seeing a lot of this unfold right now. By the time we come together 3 or 5 years from now, you're going to see a lot of these different parts, sharding sort of evaporate. API is a given for accessing a database. And being able to think about how your data works across time, just like you do when you're developing your code. I think you're going to see all of these things start to come together, and we're going to see more innovative solutions in the near future. Speaking of innovative solutions, you thought you'd get out of here without talking about GenAI, but you won't. So if you're not tired about hearing GenAI so far, I'd like to introduce an interesting use case one of our partners has created. This is a practical use of GenAI where they're already benefiting their customers, where they've managed to simplify what they've built on behalf of their customers. So John's going to take a look at what they've built already and think about how we can continue to evolve this into a multi-tenant story over time. Here you go, John.
Thank you. Yeah, so obviously over the last couple of years, we've been talking a lot about GenAI. I haven't personally. Everyone at AWS has. I think over that period, if you're building SaaS, and particularly if you're looking for your next tranche of investment or whatever, you are probably looking at where can I put this technology in my application in a way that will make it more compelling for users. At least that's the way you should be thinking about it. And I think if you look at how things have evolved over the last couple of years, and you sort of look across what different teams have done, I think there are two distinct ways of thinking about putting generative AI in your application. One of them is behind the scenes. Your users don't see it. You're somehow improving their lives, but without them having to interact with anything that looks like an LLM or an AI tool of any sorts. Or you've got features that are exposed to the user where they are quite confident that they're using something that's backed by an LLM, things like chatbots and so forth. And the customer we're going to talk about today, it's not a Scale Factory customer, I'm not claiming these guys as a Scale Factory customer, is Honeycomb.io. Many of you will have heard of Honeycomb, founder being very vocal on things like Twitter, as I am. So some of you might be Honeycomb users today. Honeycomb is an observability tool, and so we'll look at what they've done in their situation, where they've needed to lower the time to value that it takes for a new customer to start benefiting from the tool. If you can get time to value down, particularly if you've got a sort of free tier or a sort of free trial period, then if you can prove value quickly, that customer is more likely to give you money, which again, I think we all want. So the task here was to try and simplify something that's inherently quite complex in this problem domain and demonstrate the value of their solution. And what they managed to achieve was to use natural language processing to lower the learning curve and get those users more comfortable with the tool more quickly. And as a result, free tier users, 39% of free tier users were using this feature enhancement. Enterprise customers, 89%, which I think we can say is a win. And it's improved the retention and the usage of the tool for those users as well. So here's how Honeycomb accelerated customer time to value in this case. So as I say, this is an observability tool, and an observability tool is essentially the mechanism is that you take your code, you instrument it, and the instrumentation of your code pushes arbitrarily wide events out to some kind of aggregator where they can then be interrogated using dashboard tooling, query tooling, and so forth. All fairly familiar. If you've used anything like Datadog or other tooling like this, you'll recognize the model of it. And this is what you're faced with when you log into Honeycomb for the first time. It's this kind of query input that looks like it might use a language that looks a bit like SQL, and so it looks a bit familiar. But for like brand new users and maybe people who are not familiar with working with databases so much, it's a bit difficult to know where to start. And so the innovation here was to use a large language model to take an English language request and turn that into the query language. So in this case, the English language request is request response time heat map, and the tool has then generated a query in the query language that looks like it probably is going to answer those questions. So what this enables is it's an AI query, but we're still doing human troubleshooting in this case. So once you've got the heat map up, the human operator is going to need to know a little bit more about what's going on. They're going to continue to drill down or bubble up information to be able to solve the problem that they're encountering. And this heat map shows that there are outlier performance queries. And so we want to have a look at that and see why some of them look like they're taking so long. So we'll drag our box around that and bubble up the information that's within that. And from that process, we learn that the user ID that's implicated in all those slow queries is the same each time. And so we can use that information again to go and look at traces of that particular user's activity on the platform. And in this case, we can see that the checkout service has a method called getDiscounts. And in the case of this particular trace, which is one request out of that batch, the getDiscounts call is taking about 3 seconds to respond, and that's not good enough, really. So now we go and shake a developer and find out what's actually going on here. Let's see if we can troubleshoot that. So you can see it's a very kind of it's an AI augmented process, but there's still a human in charge. And I like to think of this as the sort of Iron Man situation where you've got some guy in a suit. The suit is augmenting how he's processing information, but ultimately there's still a guy there, and he's using that to troubleshoot. So if we think about what the next generation of this could be, and this isn't particularly informed by conversations with Honeycomb, this is just sort of extrapolating from there, where could we get to? Over time, you might want to collect information about the queries that each tenant is making. So customer A, tenant 1 in this case, we're going to log every query that their users are making. We're going to stick that in an S3 bucket. And then we're going to do the same for tenant 2, but we're going to put that in a separate S3 bucket because there could well be sensitive information in those queries. We should certainly be isolating this information from one another. And then we dig out a feature of Amazon Bedrock called knowledge bases, which allows us to use managed services for building retrieval augmented generation search. And so we're training essentially, or we're pushing the data that was in the S3 bucket is being picked up and pushed into an OpenSearch serverless instance as a set of vectors. And then that OpenSearch data store can then be used by the LLM that you're using to create English language interpretation of queries that people are asking in the tool. What this means is that you're now able to augment the search results using data that has a greater level of context for that customer use case. So if you have a new developer who's coming to use the tool for the first time, they're using the natural language search features, the suggested queries that are being generated from that are informed by all of the searches that their colleagues has made over the time we've been collecting that data. You can see that becoming more powerful over time. So what I think this leads to, and where I think I'd like to see some of this going, I think the sort of the agentic approaches that we were talking about in the keynote this morning kind of have the same sort of idea behind it, is that rather than this being an Iron Man suit kind of situation where there is a person in there still making decisions, maybe that system can learn what sort of queries and troubleshooting we are regularly doing on our platform and start preemptively looking into stuff for us. So rather than doing that sort of drilling in and digging down and identifying problems and then going and shaking a developer to find out what's going on, I think the future state of this is that our tooling is learning how our solutions evolve over time, learning the types of ways in which we troubleshoot them, and helping us do that without us having to go through this sort of manual or semi-manual thinking process. That's where I'd like to see this get to. I think there is scope for this to become a reality over the next 3 to 5 years. Bill, I think you're going to talk about some additional SaaS sessions that are going on at reInvent.
Absolutely. So we've missed a few. So all of the breakouts are recorded, so you will be able to see these on YouTube in just a couple of days. But the ones I've highlighted in green here are still happening in the future, especially we did talk about SaaS Builder Toolkit today. You can see SaaS 406. That's going to happen on Thursday, I believe at 12:30, if I'm not mistaken. You can see some different things in here around DevOps and multi-tenant EKS as well, which relate to the topics we've talked about today. And they dive much deeper than we did into each one of these individual topics. We have Chalk Talks, and we also have workshops. If you haven't attended one of our workshops, please do. There is an SBT workshop as well. That'll be really exciting. That's Thursday, maybe 4:30 or so. So check that one out. And there's also one on SaaS and RAG. So if you're interested in what we were talking about in terms of using knowledge bases to build multi-tenant SaaS applications, they'll dive really deep into that. That's a great workshop. And a couple builder sessions as well. So with that, please, if you could take a minute to fill out your surveys, this helps the people who are organizing reInvent to pick the sessions for next year. So if you vote for SaaS sessions, you'll see more SaaS next year. If you don't, then we might not be back, and I like being here. So please vote for us. My name is Bill Tarr. You can see my contact information here. Don't hesitate to reach out. If you got SaaS questions, if you have SaaS stories, John as well, of course, is always willing to have SaaS conversations. Thank you all for coming.